for us because in the past the old theory suggests that electrons can only be accelerated in one direction, in both directions. But in our new finding, we observed not this bidirectional acceleration, but in fact, plasma line enhancement was only observed in the downshifted channel. The altitude of the enhancement. The altitude of the enhancement corresponds to the height of the F region plasma, as shown in the video plots just now. And I'd like to point out that in our more detailed analysis, we actually saw that the peak normalized radar power that was recorded corresponds to the location of the greatest plasma density. So there's a correlation between that plasma density and occurrence of this electron acceleration. And also, in just a previous slide, I showed that there's a dependence on spread of conditions. This also makes sense to us because when there's spread of conditions, it reduces specular reflection along the ionospheric profile. And as a result, this VR wave can couple more easily into the plasma, and as a result, cause more electron acceleration. So the plausible new mechanism that was proposed by us was the fact that if you take into account that the Whistler wave is a rather small wave vector, the Whistler wave has a rather small wave vector compared to those of simultaneously excited irregularities field line modes. Lower hybrid waves can actually excite Whistler wave via the interaction that I showed you with the wave vectors, and they'll have this asymmetric parallel wave vectors excitation. So, in other words, lower hybrid waves would have a preferred upward propagation direction, and this preferred upward propagation direction can possibly result in this asymmetrical downshifted channel versus upshifted channel electron acceleration observation. We do understand that currently there are various weaknesses in this particular mechanism that we propose, but this is the best that I could do with the data that I had. Now what we intend to do is actually to obtain data from this on-site measure and a very pro interferometer device, and hopefully using this 2D device we can correlate and find gain more insight into this plasma feature. So I'd like to acknowledge some people that helped me along the way with this thesis, and I'll take any questions now.
One short question. Somewhat short question because we're running a little late.
I have too many questions, but I guess I'll just. So the Whistler mode is thought to trigger the precipitation.
Yes.
It produces a plasma line.
Yes. So what happens is that when you excite Whistler waves, you have a wave vector and the electric field excited at the same time.
Now, how do you know that the null hypothesis would be that precipitation was going to occur anyway, because there is of course Whistler wave activity in the magnetosphere over Arecibo. Yes. So, would it just take a longer duration study to determine statistically cause and effect between the NAU facility and the Wagner wave enhancement?
Okay, so what happened is in the December 2004 experiment, they actually turned off NAU for a short period of time. We saw that during this turning off of NAU, what was observed is that there was a lower frequency of plasma line enhancement, and when the NAU subsequently turned on at about 2 a.m., we observed a lot more plasma line enhancements. So using this, we can actually correlate and find things.
Thank you.
Thank you. I think in the interest of time, we should go on. Questions can continue offline. Thank you very much.